Hello and welcome back to Batee Corvette Repair. My name is Bryan Thompson. Today we're continuing with the troubleshooting series. Today we're going to check out this 87 instrument panel from Timothy B. Unfortunately, Tim didn't supply any information about the problem he was having. All right, when I power it up, I notice that all of the segments come on. I can read the speedo and all of the segments are working. I'm having some trouble reading information in this area, so we have faded polarizing film on this panel, but I definitely see all of the segments coming on and off, so I think the panel is restorable. This panel I can't see at all, so I'm going to have to get some polarizing film and check it out. The way the polarizing film test works is we hold it flush against the LCD panel and we rotate it. What we're looking for is to see not necessarily that it looks factory, but that we can see correct information on it. The reason it's never going to look factory in this this test is because we not only have a new piece of polarizing film, we're also looking at the old faded polarizing film, and it just doesn't ever look factory. What I'm looking for is, do I see all of the segments lighting up? And then resolving to a 0? I do. I'm going to go ahead and enable my signal generator. It's really hard to see on camera, but we're definitely seeing the instrument panel read 60 here, which is what it should. And I see these other segments in the bar graph lighting up, so I think the TAC panel is working as it should as well. While I have the speed signal applied, I'm looking for the odometer to rotate at about 1/2 RPM, and it's doing just that, so that the odometer assembly is working as it should. Okay, let's go ahead and pull the back off and find out what's going on inside. We've got the back off now. The first test, we're going to push in the area of the board connector set. This is the white 12-pin connector set. We're just looking for broken solder joints here, loose connections in that connector. We'll physically examine it later when we reposition the camera and check it for any hot spots. While the cluster is powered up here on the bench, we're going to push the power supply and make sure we don't have any intermittent issues there. This appears to be good. Okay, so let's take a look at the back. Here we see the back of the cluster. We're going to go ahead and remove the odometer connector. We've already tested that. We don't need to continue to add miles to Timothy B's odometer. What we notice is that this is a replacement power supply. This is not a Batee power supply. This is a replacement power supply that came along in 1990, so it does have some years on it. It's got much smaller filter capacitors on it, and for that reason, it's probably not going to last as long as the factory power supply did. But right now, I can't show that it has a problem, so we're going to leave it alone. Next, we're going to look at the 12-pin connector. What I'm looking for here is, do I see any broken terminals? I do not, and it's working like it should, so that's not a surprise. But I do see some heating that's occurring on some of the center pins here, and that tells me that we're going to have some broken solder joints underneath or some broken solder joints sometime soon. The reason the heating happens, the reason the discoloration happens, is the contacts lose their spring tension over time, and they'll develop a little bit of a resistance, and that resistance causes heat, which causes the spring tension to be even less. And it's kind of a vicious cycle. Eventually it will melt itself. So I'm probably going to recommend to Timothy that we replace this connector set. I don't see any other major issues here. The most common other issue that I see is a broken crystal in this location. If the cluster is not booting, check for a broken crystal here. Okay, let's go ahead and take the top board out and have a look. All right, here we see the top of the bottom board. This is the LED lamp driver board. The first thing that I notice is that it has the wrong bulbs. These are marked PC168. That bulb is approximately half of the wattage of a typical factory bulb, which is why we're not seeing a very bright image on the LCDs. We'll replace those bulbs at the same time that we replace that connector set. What we're looking for in this connector set are, do we see any hot spots? And we absolutely do. On this this pin, which is the ground pin, we see that it has discolored to the point that it's lost all of its shininess. It's almost starting to turn black or like a blue color. So we definitely need to replace this connector set. The next things that I'm looking for are what are the condition of this electrolytic capacitor. It's very common for this capacitor to separate. It's very common for this capacitor to explode if the car has experienced a 24-volt jump start. This one looks pretty good. So I'm going to pull the bottom board out and we're going to take a look at the back side. Something that I forgot to mention, I'm wearing my anti-static wrist strap, which is grounded. We're also working on top of an anti-static mat here on the bench to avoid damage to this bottom LCD driver board. It is very static sensitive. If you don't have one of the static straps, we sell those for less than $5 in our web store, and they're definitely good insurance. So we're looking at the back side of the bottom LCD driver board. What we see here is that it's got some common discoloration around the bulbs, but that's nothing major. We see broken solder joints at both the power and ground sides of that 12-pin connector set. And again, the reason for that is that they're developing, the connector is developing heat, which is causing those solder joints to fracture. We're going to go ahead and replace this connector set and resolder all 12 of those pins. And the next thing that I notice is when I look at this photocell, it almost looks cloudy. It looks, I should be able to see a distinct sine wave pattern in that photocell, and I kind of can't see it. And the reason for that is that it tends to fade in the sunlight the same way that the polarizing film does. And it kind of develops this hazy look, which indicates it's either not working the way that it should, or it's not going to last very much longer. So as a part of our backlight repair service, we will replace this component anyway, so not a problem. Next, I want to show you the heat damage that I'm seeing around these light bulbs. We'll zoom in here in a second and show you the actual damage, but right now what we see is definite discoloration of the fiberglass circuit board around all 4 of those bulbs. And that's common. That's not a problem in and of itself. If the board starts to delaminate in the area of the bulbs, then it is possible that the bulbs won't make good contact with the power traces on the back side. And if that happens, we might need a replacement, but that's fairly infrequent. We have artificially increased the brightness here so that you can see what's going on, but basically what we see is a circle around each of the 4 bulbs that is darker in color than the rest of the circuit board. That's the heat damage that we're talking about from those factory bulbs. If you want to avoid this, you can use our halogen bulb kit for a factory look. The xenon bulbs have a factory look, but generate about 50% less heat. And the LED kit that we sell doesn't exactly look factory, but it generates just about no heat. So there won't be any further damage from the factory cluster bulbs. The speedo panel that was working as it should, when we view that without the bulbs on, in other words, the keys off, the clusters off, what we see is that the panel looks just about black. We see no colors poking through any of the polarizing film here. When I switch over to our faded panel, which we can see is just clear at this point, when I view that with the color filter behind it, the key's off, and yet I see all of the colors. When I see those colors, it tells me that my polarizing film is faded and needs to be replaced. Now I'm going to show you the center panel. This is kind of a weird situation. What I see is that the center has kind of an oval shaped part that is turned clear, and the rest of it, there's a black ring around that where the polarizing film hasn't faded yet, and this is fairly common to see. So that's what it looks like when we view the cluster with the key off. We see colors forming in the middle. We see sort of black in the periphery. This indicates a partially faded panel. In order to fix this, we would need to replace the polarizing film. All right, and finally, I'm going to check this color filter. It's fairly common for paint to stick to the color filter, and that will definitely cause a non-factory blotchy appearance on the LCDs. So we want to try to clean that if we can. This one looks just about new. So I'll dust it off with some compressed air and go ahead and use it as is. Looks fine. That wraps up this checkout of Timothy B's 87 Corvette instrument panel. For more how-to videos like this and the parts to fix your instrument panel, check out Batee.com. That's BATEE.com. Thank you.